Earth, our home planet, always either too hot or too cold, depending on where you are. But how did all of this even come to be? Most scientists believe that about 10 billion years ago, our solar system was nothing more than a massive, chaotic cloud of dust and gas, a kind of under construction phase of the universe. Thanks to gravity, this cosmic mess started clumping together, spinning and flattening into a giant disk. The center of this disk became the sun, basically the light bulb upgrade for our system, while the outer chunks merged into planets. Around 5 billion years ago, these planets were as scorching hot as a fresh out of the oven pizza. But gradually cooled down, and voila, here we are. But how do we even know all this? After all, the deepest hole humans have ever drilled is only about 8 kilometers deep. Compared to Earth's interior, that's like trying to understand a car by peeking through the keyhole. The answer? Earthquakes. Every year, over 100,000 earthquakes shake the planet. Most are harmless, but they all send shockwaves racing through the Earth. Scientists use these Earth scans to figure out what's happening below. There are 2 types of waves: P waves, the fast movers that travel through everything, and S waves, the picky ones that only move through solid materials. By studying how these waves spread, researchers get a pretty good picture of Earth's interior, basically like a CT scan, but without the waiting room. And then there's Earth's magnetic field, our invisible superhero that protects us from nasty solar storms. Centuries ago, people thought compass needles pointed toward the North Star. Today, we know that Earth itself is a giant magnet, with 2 magnetic poles that slowly drift over time. Scientists think this field is generated by electric currents in the liquid outer core, a natural dynamo that works 24/7 without ever taking a break. Earth's magnetic field has changed a lot over time. Around 500 million years ago, the magnetic North Pole was near the equator, right where it's warm and sunny today. Who knows? In a few 100 million years, the North Pole might be in Italy and Greenland might have tropical beaches. That'd be a change. We usually expect the ground beneath us to stay still, but in some places, Earth has a habit of shifting, cracking, and toppling entire cities. Yep, earthquakes. But why do they happen? Earth's crust is actually just a thin, brittle shell floating on a much more flexible layer underneath. Think of it like a giant layer cake with way too many layers, only not as tasty. Under constant pressure and internal forces, these rock layers either bend or snap, and when they do, we feel it as an earthquake. Fault lines are especially active zones, like California's infamous San Andreas Fault, where massive chunks of rock are constantly grinding past each other. In 1906, this fault nearly wiped San Francisco off the map. Today, small tremors happen there all the time, usually harmless, but you never know. Now onto mountains. They might look like they've been standing forever, but they actually have a pretty dramatic history. If we could cut through the Alps or the Andes, not a great idea geologically, we'd see that these rock layers have been folded, squeezed, and stacked over time. In fact, many mountain ranges used to be the ocean floor. Fossilized sea creatures found at the top of the Alps prove it. Thanks to massive forces deep within Earth, these flat rock layers were pushed upward to form mountains. But nature wouldn't be nature if it didn't try to tear them down again. Wind, water, and ice are constantly working to erode them away. Speaking of destructive natural forces, volcanoes. These fiery beasts form when magma from deep within Earth pushes upward. Magma is basically molten rock, a sort of geological lava latte. When it breaks through a weak spot in the crust, you get a spectacular show of lava, ash, and gas. Over time, layers of lava build up to form volcanic cones, kind of like a magma pizza stacking itself slice by slice. Some volcanoes stay active for years, while others take long breaks until pressure builds up again. Then, boom! But not every hot zone leads to an eruption. Sometimes, magma just heats up groundwater, creating natural phenomena like geysers, steaming fountains that blast water high into the air at regular intervals. It looks impressive, but it's basically just a natural pressure cooker. In Iceland, they even use this geothermal energy for heating. Pretty clever, considering how chilly it gets there. And then there's the ocean. When Earth cooled down, it rained for thousands of years, basically a never-ending downpour. Eventually, enough water collected to form the oceans. Rivers have been washing dissolved minerals into the sea ever since, including loads of salt. That's why ocean water is salty. And since the salt levels haven't changed much over millions of years, they probably won't anytime soon. Speaking of the sea, ever notice the tides? That's the moon's gravitational pull, literally dragging the water around and creating massive tidal bulges. The same thing happens on the opposite side of Earth, thanks to centrifugal forces. And when the sun and moon team up, we get extra strong tides called spring tides. So yeah, a lot of forces are constantly shaping and moving our planet. Next time you're standing on a beach or hiking up a mountain, just remember, this planet is anything but static. And that's it for now with our little earthquake of knowledge. The Earth might not be perfect, but hey, it's pretty awesome. Or hot, depending on whether you're currently hiking up a volcano. If you enjoyed the video, give it a thumbs up, subscribe to the channel, and let us know in the comments if you've ever tried roasting marshmallows on a volcano. Spoiler, not recommended. See you next time, and don't forget, stay curious.